What's up, guys? So I got called out to a customer's house today. I'm going to be replacing 2 toilets for them. They also have a outside faucet that's leaking, and then also I'm going to be doing a maintenance on their heat pump and air handler system. So stay tuned.
That's a good boy. Hi. Hi.
Okay, so we have a Bosch 4-ton air handler here. Alright guys, so one of the most important thing is making sure that the airflow is set properly. Now this is a 4-ton system, so we're referring to the sheet here. 48K, that's 4-ton, so it has SW6, 1 and 2. 1 should be off and 2 should be on. And we got 1 is off and 2 is on. Now 3 and 4 refers to, this is a delayed on the fan coming on or off. And 4, it looks like it's reserved, so this is a setting that's not used in this application. So the most important thing is always checking airflow before you check refrigerant pressures and temperatures. All right, now I'm waiting for the system to come back on. The next thing I'm going to be doing here is we're going to be checking the temperature split, which is the delta T between the supply and the return. Now a system should be around 20 degrees is ideal, to 20 to 30 in that range. This kind of information here will kind of give us an idea of what the charge is like outside without actually putting our gauges on it. But we are going to confirm that also. Now it's best to let the system run for about 20 minutes. Now another thing we're going to be doing as well is checking the static pressure of the system. So that is the pressure that is built up inside the ductwork between the supply and the return as well. Now these systems are based on a 0.5 static. 0.5 and under is ideal for the system. And then anything over that means you have high static. And at that point, what you want to do is make some renovations to the ductwork to make sure the ductwork can handle the equipment. Now the thing about these units now you can see this is the equipment interface module, and this system has 2 stages. So there's a single compressor stage and then a second. Now what we want to do is wait till the system's up to its second stage. Now the way this system works is the outdoor unit responds to what the indoor airflow is. But when we're checking static, we want to make sure in the delta, we want to make sure we're checking out on the highest equipment stage. Okay, so the unit is kicked into the second stage. Our supply static on the higher side is 0.25. You can see it's fluctuating a little bit here. Okay, now we got a return static. Now to find your total static, all you do is you add the two together. So we had 0.25 on the supply. On the return, we got about 0.25. So this system is running at 0.5 or under on static, which is excellent. Now it would be ideal if I could read the static pressure before the filter here, because the filters are restrictive. It'd be ideal to read it just from the equipment itself, but I don't feel comfortable drilling into the cabinet of the unit. I'd rather just do it in the ductwork so we can count for a little bit with the static pressure drop of the filter. Okay, so our supply discharge air is 49.3 degrees. Okay, now our return air temperature, we have 67.2. So that puts us around 22 degree delta. So that's a great temperature split from the system. Now we're going to go and check the outside. Okay, so I got my gauges hooked up. So this system uses a thermal expansion valve, so we're going to be checking for the subcool. Now you can see our saturation. So this is a 410A system. So right here we have our saturation temp, which is about 82, 84 degrees there. And our line temp, 76. So So we're at a 8-degree subcool, which is perfect for this system. Now you can see the coil here needs to be cleaned. It's not horrible, but it's definitely a little bit dirty. So that's the next thing we're going to be doing. And then also, here's the attic drain. It's draining pretty good here, but we're also going to clean that drain as well.